Superhumanize. Accelerated evolution.
Today on Superhumanize, we're focusing on the heart of health with Dr. Stephen Hussey, whose work bridges evolutionary biology and modern wellness. Dr. Hussey, a chiropractor and functional medicine practitioner, brings a unique perspective on heart health, diet, and the evolution of human wellness. From his own health challenges, including a diagnosis of diabetes at a young age, Dr. Hussey has carved out an approach that challenges the conventional narratives around heart disease, dietary fats, and the role of nutrition in our lives. In his work, Dr. Hussey emphasizes the importance of understanding heart health through the lens of our evolutionary past, questioning the vilification of cholesterol and highlighting the limitations of current medical paradigms. His insights into the fluid dynamics of the cardiovascular system, the metabolic preferences of the heart, and the critical roles of stress and diet and heart health are reshaping how we think about our most vital organ. I invite you to join us as Dr. Hussey shares his groundbreaking insights and practical strategies for nurturing a high-performing heart, leveraging the power of diet, and rethinking our approach to health and wellness. Stephen, welcome to the Superhumanize podcast. It's such a pleasure to connect with you.
Yeah, thanks for having me. Happy to be here.
Absolutely. I am thrilled we get to talk about one of the most important parts, organs, amazing evolutionary developments in the human body, which is the human heart. And in your book, Understanding the Heart, you discuss something that I found fascinating, and that's the fluid dynamics of the cardiovascular system. Could you explain how these dynamics contribute to common misunderstandings about heart disease prevention and treatment as we experience them today?
Yeah, for sure. So I'll have to give some background of the underlying physiology that drives us towards this understanding. I came across a lot of evidence in my, search for understanding physiology and health in general that the heart is not the main mover of the blood, which is what we're all taught in physiology classes across the world. But there's a very large body of evidence that suggests that it's not. And even early researchers in the cardiovascular system, where they had their doubts that a heart our size could move fluid effectively throughout the entire body. And so it turns out that a heart our size is probably, if you look at it as a true pressure propulsion pump, something that does move fluid, it's about 15% effective at doing that, somewhere between 15 and 20. Which doesn't really make sense to me why something, whether you believe we were evolved or created, like why would that have happened? Why would it be 15% effective at doing its job? And it's because its job is not to move the blood. So the heart has three purposes, which we can talk about, but people are probably wondering, how does the blood move then? There's a lot of water in our bodies. We're told we're a large percentage water, 70 to 90% water. And that water is actually not in, or most of it is not in a liquid state we know of as water. It's not in an ice state either. It's not frozen. It's between solid and liquid. It's more like a gel. People can think like Jell-O, or when you put bone broth in the freezer or the fridge and it turns gelatinous, that kind of stuff. And if you just take the tissue of your forearm and you move it, it feels like a gel, right? You can push it away, but it comes right back, right? And so most of the water in our bodies is in this gel state. And it turns out that water like this does form on the lining of the arteries, as long as we're getting adequate energy to the system. So water has the ability to hold energy. And when it holds that energy and it gets next to a biological surface, a water-loving surface, which all biological surfaces are water-loving, it will structure itself. So what happens is the water actually cleaves off one of the hydrogens of water, and it leaves an oxygen and a hydrogen left. And those oxygens and hydrogens team up with other oxygens and hydrogens, and they make this lattice-like structure that stacks up on itself, and it looks like this gel. And so this gel is lining the arteries. And there's two things about that gel. One is that it's also called exclusion zone water because it excludes anything that's not it. So it keeps things away from that surface, which would protect the lining of our arteries, which is something people are very concerned with these days as far as heart disease. But the other thing, that because of the way structured water forms, it's a very electronegative, it holds a very electronegative energy. And because it cleaves off one of those hydrogens that's very positive, the hydrogens line up next to that electronegatives area, and we have a positive and a negative charge separation right there. And that is a battery, which everybody puts batteries into something, has to align the positive and negative end. And so that battery that's created there by structured water formation does the work of moving fluid in the body. And this happens in the cerebral spinal fluid, happens in the lymphatic fluid, but it happens in the vascular system as well. And so that's how blood moves. Now, there's other ways that it moves too. This structured water also gives the elements of blood electrostatic properties that kind of help drag everything along with it. There's also something called paramagnetism, where the iron in the blood is attracted to magnetic fields, which tissues and organs have magnetic fields that attract the blood to it. There's different ways that blood moves, but that's the main one, is structured water in the lining of the artery. So that totally flips things on its head as far as we talk about something like heart failure, right? So in heart failure, we're seeing the heart as failing. That's what it's labeled, heart failure. The heart is failing at moving the blood. However, the job of the heart was never to move the blood. It does do a little bit of moving, but no more than enough to get the blood through the chambers of the heart itself. And if we're saying heart failure is just failure of the heart, it's actually not. It's actually failure of these other mechanisms in the body that are not moving blood. And how do we build these mechanisms, right? How do we build up structured water in the body? And that is bring energy to that water, energy in the form of light, in the form of touching the earth, grounding, in the form of movement. There's lots of ways you can generate electrons, energy, to structure that water and move that blood.
That's very cool, Stephen. And I would like to go into a little more detail regarding this, because I know probably a lot of people in the audience are like, okay, how do I better help structure this water? You already mentioned it with light, with grounding. How else? I know you're a big fan also of infrared sauna. I have one here at home. Give us a few more pointers to what we can actually do. Some a basic level where everybody has access to, and some for the people who are already deep in this extending health span, lifespan space and want to know what's the most cutting edge thing that they could add.
Yeah. So life in general is all about harvesting energy from your environment and using that energy. Order is defying the second law of thermodynamics, which is things tend toward disorder. But life takes energy and maintains order to sustain life. And that order is maintained by accumulating charge to your body. We all hold this net negative charge. If people are familiar with cellular physiology, they know that each cell has a net negative charge to it. And the problem with today is that we have a lot of things that are stealing that charge. So any way that you can get these electrons into your body, this charge, will enable water to structure itself and hold that charge. Structured water is what's responsible for that net negative charge in cells. People think it's cellular proteins and the sodium potassium division, which are things that contribute as well, but it's mainly structured water in the cells. And so that's what allows water to structure itself onto the lining of the arteries and the lining of the elements of blood, like red blood cells and lipoproteins and things. And in Dr. Gerald Pollack's lab, who's at the University of Washington, and he's probably one of the foremost researchers on structured water today. There's been many in the past, but he has found that infrared light is the most structuring to water, specifically the 3000 nanometer wavelength, which is the farthest on the spectrum, the far infrared of light. So like the sun gives off, everything from UV to infrared. It's like 250 to 3000 nanometers. 3000 is the far end of infrared, and that's the most structuring to water. When you shine that on things in his lab, it builds the structured water in whatever he's using to study that, including the vasculature of animals. And so that's why I use infrared sauna, because it's a little hack, a modern day hack that you can use, because that's not, obviously, we wouldn't have had that in the past, but these days with all the things that are contributing to the stealing of that charge, it's a modern day hack that I can get this concentrated dose of infrared.
Quick insertion, more details on this, Stephen. So I have an infrared sauna, near and far infrared light, a few other little gadgets as well. How often do you recommend using the sauna if you have one?
Yeah, so in the winter, more, because we're not outside as much. Although I get out in the winter where I am, I can. And surprisingly, even down to 30 degrees, if I'm in the sun, I feel pretty good with that sun on, because the sun's rays are 42% infrared. But in the winter, I still use the sauna more. Whereas in the summer, I'm definitely outside in the sun getting that sun less. But generally, 4 to 6 times a week for about, I wait till I start sweating and then I stay in for 5 more minutes and then I get out. But it's not really about the heat level or the amount of time you spend in it to get up to sweating. It's really just about the infrared exposure. So even if you just opened the door, or I just have a little tent version. So if I just unzip the tent and I don't get that hot, like I'm still getting infrared exposure, which is really important. But there's different benefits to heating your body as well. But the infrared is to me most important. So that's my routine for it. But yeah, other ways that you can get energy is direct contact with the earth. So the earth is this very large reservoir of electrons because the sun, and all of this comes from the sun, but the sun is concentrating energy into the ionosphere. And then when that energy gets excited, like in a thunderstorm, that comes down to earth and it strikes lightning onto the earth, which deposits electrons into the earth. And then we contact the earth. And the laws of electrostatics tell us that if two conductive surfaces get next to each other, then the one with higher concentration of energy will flow into the one of lower concentration. And I'm never going to be as concentrated as electrons as the earth, so it's always going to flow into me. So contact with the earth is one way to do it.
And let's dissect that a little further, Stephen. So, because this is one of the things that for a vast majority of human beings nowadays, especially those of us who live in urban centers, we don't have contact to the earth. We wear shoes all the time. In our homes, we wear socks or other stuff. Plus, it's not on the earth. So, what can you do, and what's the minimum you ought to do in order to get this contact to the earth? Or are there maybe also some devices you can use if you literally live in a concrete desert and there's just not a single tiny patch of earth around?
Yeah, definitely. Yeah. And so there's definitely devices you can use. I mean, the best is always going to be bare skin on the earth. If there's not that, there are devices that people make that you can plug into the grounding prong in your outlet in your home that's technically supposed to be grounded, although you can check that with little grounding testers to make sure that it's truly grounded, or that there's even a grounding wire there. Because sometimes in older homes, it's just a two-prong system, a two-wire system in the home, and someone's installed a three-prong plate on the thing, but there's no grounding wire. You have to test for that, make sure that there is one. And then there is some concern with like dirty electricity as far as crossed wires in the wall and things like that, bringing it in. But yeah, there are devices like grounding sheets or grounding mats that you can plug into those prongs. Like my feet are on one right now, a grounding mat, and you can be getting that when you're not outside. Even if it's like we're barefoot on the earth, it's still more than you would get if you weren't on the grounding mat. Yeah, it's different things like that. And then as far as a limit, like any amount is going to be beneficial, but obviously the more the better. Just so people get an idea, anytime I can be on a grounding mat or a grounding sheet or outside with my feet barefoot on the earth, I'm doing it. So just get as much as possible. There's no like dosage that's going to give you some visible benefit. Like it's all going to be different depending on the person. So just get out there as often as you can and be in that constant supply of energy. Yeah.
So we have infrared, we have grounding. What else would you recommend?
Yeah. Moving your body. We have this fascia system in our body that holds our body together. And it's thought that, at least many people think that it's this fascia that just connects one organ or one tissue to the next and holds things together, but it's actually interwoven very intricately throughout the entire body, all the way down into the cells, into the nucleus of the cells. And the movement of this fascia, because the fascia are collagen proteins, and the movement of it, which the water around them, they're hydrated. When you move them, they have piezoelectric properties, meaning that when that water that's structured onto the fascia moves or is compressed or stretched, it actually creates this charge separation again, which does the job of creating DC electric current. That's electrons, right? So when you move your body, even just gentle stretching has been shown to decrease inflammation, because that's what increasing this charge in your body is. It's just decreasing inflammation, because inflammation is lack of charge. So just gentle stretching and movement especially movement to the point of creating heat, because generation of heat is the energy production from your mitochondria. And your mitochondria don't just make ATP, they make CO2, obviously. They make water, they make perfectly structured water, and they make free radicals, which are signaling molecules. Those things are very important for maintaining the structured water as well.
Excellent. Please elaborate on inflammation is a lack of charge.
Yeah. Yeah. If you look at the research, when something gets inflamed, like whether it's chronic inflammation from someone who's got inflammation in the body, or whether it's acute, like you injure yourself and the body is inflamed, it's lack of charge or it's inability of cells to hold charge. So, like when you get injured, the cells become damaged and they have an inability to hold charge. And that's what pH balance, this acidity negativity in the tissues. And that is what the sensory neurons pick up and relay to the brain, and the brain sends a pain signal. So that's what pain is, one aspect of pain. And so when someone's in chronic inflammation, it's because their body has, or at least an area of their body has a decreased charge, a decreased negative charge to it. It's more acidic. It's more positive charge, more hydrogen ion concentration, that kind of thing, which is what happens when you go for a run and you feel muscle burn in your leg. It's hydrogen ion concentration and lactic acid concentration in that area. It's this inflammation, which ends up being a hormetic stress that's good for you in the end. But if we have chronic inflammation, it's just your body's got low negative charge. And so if we want to change that again, we have to increase the electrons into our body and decrease the things that steal that charge from our body.
Stephen, thank you for explaining this. And to circle back to the beginning of our conversation, where you illuminated that the heart is more than a pump, you mentioned that it actually has three main functions. I would love to learn more about that.
Yeah. There are many ways that water can absorb energy. One is we talked about infrared light. Another one is the vortexing or swishing around of water in the presence of oxygen. So this is what we would see if water was coming out of a natural spring or flowing in a river. It's getting tossed around. It's turbulent, right? And in the presence of oxygen, then which the blood is always full of oxygen, even if it's the venous blood, it still has oxygen in it, is being vortexed around or swished around in the chambers of the heart. If you look at the heart, the way, first of all, it's one big band of muscle that's wrapped up and folded up on itself that forms the chambers of the heart. And so when it contracts, it does so in a spiral-like nature. And so when it does that in the ventricles, it kind of vortexes or swishes around the blood. And then also when blood flows into the chambers or out of the chambers, it kind of eddies on the other side. Like when water flows past a rock in a river and it swirls on one side of it, that vortexing is creating energy in the water. Dr. Pollack has shown this in his lab. And so the heart is this vortex that does that, so that it structures the water a little bit to an extent so that when it gets into the periphery, into the arteries and veins, it can structure itself on the lining of the artery and promote that blood flow. So in a way, the heart is responsible for some movement of the blood, although just the vortexing caused by the heart is not enough to fully energize the blood on its own, and it would get overwhelmed in doing that if it was left just to those devices. That's why we need the infrared light exposure and the grounding and things like that as well. So that's one purpose of the heart, is it's a vortex to spiral the blood as it moves through it. The second function is actually to slow the flow of blood. So during exertion, our tissues demand oxygen and nutrients from blood. And so when we start to exercise or get stressed about something, then all the blood would flow over to the arterial side, trying to deliver nutrients and oxygen to the tissues. And if the heart wasn't there to slow the flow of blood, then all the blood would, or too much blood would flow over to the arterial side, reducing the pressure in the venous side, and the venous side would collapse, which would cause us to die. So the heart is actually there to slow the flow. And they've actually shown this in studies of endurance athletes, soccer players, that the hypertrophy we see in the heart in endurance athletes, it's better at stopping and blocking the flow, like catching the blood almost, so that it can redirect it back out, which is interesting that it flips things on its head like that. So it's there to maintain pressure between the two systems. And then the third reason, or the third function of the heart is more sensory in nature. The heart is a sensory organ, and it senses our emotional state. And it also senses what's called coherence in the body. So there's a reason we say things like, I love you with all my heart, or I gave it all my heart, or I put my heart into it, because the heart is incredibly associated with our emotional state. And so it is interpreting our emotional state and relaying that to the brain, so the brain can have the appropriate response and signal the body to have that appropriate response. Also, it's measuring something called coherence. And coherence is when a system is synced up and communicating to the extent where each individual part can contribute to the system as a whole and do what's best for the system as a whole. So that's what each and one of our cells are doing. They're communicating to other cells, whether it's through the nervous system or electromagnetically to other cells, and how synced up and communicate gives off the biggest electromagnetic field, 5,000 times stronger than the brain's. And it's the only organ that has an electromagnetic field that's big enough to be able to, quote unquote, touch or sense every cell in the body and get a sense of how synced up and communicating they are. And based on that, how synced up and communicating they are, that's a measurement of coherence. And that's measured through heart rate. Body's picking that up. So if you have a tissue or an organ that's not synced up, not communicating well, or certain cells, then the heart picks that up and that interferes with coherence. And your body gets an incoherent, or your heart gets an incoherent signal, which is relayed to the brain, and the body is in a more state of stress, like, something's wrong, right? And so tissue damage or cellular dysfunction and things like that can all contribute to that. But yeah, those are the three functions of the heart. That's what it's there to do.
That is fascinating and also really beautiful, Stephen. Have you also looked into the more metaphysical aspects of this, especially the heart as a sensing organ?
Yeah. So, I mean, we all give off electromagnetic fields, all of us, and the heart has the biggest. And so, like, again, there's a reason that we intuitively say things like, she touched my heart, that kind of thing, because it is the organ that's allowing us to sense our environment, and we can sense other humans. I think we can all relate to a situation where someone around us is giving us a bad vibe, even if they're not saying anything to us or necessarily doing anything. We get a bad vibe from that person. And some of that can be mental, like preconceived thoughts about something, but sometimes it's just an intuition or just a bad feeling about something. And that can come from the heart. But how coherent or incoherent we are is also, and some people see this as pretty woo, but there's actually a lot of evidence for it. It dictates how well we can connect to the field through which we all communicate, which people have called this many things throughout human history, whether it's God or prana or Yahweh, or now ether is the more physics term for it. And it's basically the idea that nothing is really empty space. It's all filled with a medium through which we communicate. Like radio waves have air that they travel through, and waves in the ocean have water that they travel through. There has to be a medium through which light, which is what electromagnetic energy is, it's a wavelength of light, travels through. And that has been termed in physics ether. And so that's the medium through which you and I could communicate, so to speak, whether we're right next to each other or far away. And some evidence, again, people may be thinking, this is crazy, but there's evidence that lots of different studies that they've done where groups of people come in and they concentrate, like meditation wise, on an area or a population, or for a given thought or an idea or a mentality. And they see changes in behavior in populations when people do that. There's studies where I think it was like in DC, like the crime rate was really high or whatever. And they sent in a bunch of people, I think it's like up to 50 people, like to various places in the city. And for 3 months at certain times of the day or whatever, they would all concentrate on the same thing, like peace and nonviolence and this kind of stuff. And they saw crime rates drop dramatically. And the police chief was just like, we never see this. Like this time of year, it's always this high. And it's the highest it's ever been this year. And we don't know. We can't explain why it drops so dramatically. So it's just that these things can be effective. And there's a lot of studies that kind of provide some evidence for like collective consciousness. Like when groups of people think the same thing and have a certain intention for something, it has an effect. And the argument is that it's through this ability to connect, and the heart is what gives us that ability to connect. So it's like this heart-centric thinking, and the Heart Math Institute talks a lot about this. But yeah, so it's really interesting to think about that aspect of our physiology and how we're out of touch with it.
I agree with you 100%, Stephen. And I highly recommend what you just mentioned for anyone who is intrigued by this to check out the Heart Math Institute's work on all of this. And I'm pretty sure most of us have experienced what you also described before, where you just get a bad vibe from someone, or the opposite, where somebody enters your field and you just feel so good immediately. And it is something about the, let's use the word vibe. Let's
Mhm.
use the word frequency. It's something that emanates from the person, some information we pick up, a part of us picks up upon. And these things can literally influence a room, a whole city, an individual that's in front of you. And I think it's something we absolutely individually and collectively need to look more into. There's a reason why certain cultures have practiced mass meditations very regularly. It's a truly fascinating and beautiful thing. Thank you for sharing your perspective on this, Stephen. Let's go back to some of the more physical stuff. With regard to heart health, there's also a lot of misconceptions about cholesterol. And you've talked about these misconceptions surrounding cholesterol and heart disease. And I would like to learn from you, what are the most persistent myths and how do they affect our approach to heart health?
Yeah, I think that this cholesterol, the main issue historically with the cholesterol theory of heart disease, it's been a giant distraction from the actual causes of heart. That's the main problem because it has dominated the space in Western medicine, at least, to solely focusing on diet, which is important, and measuring lipids in blood. That's the way they assess for heart disease. And then we're ignoring all the things that we just talked about that influence the physiology of the heart and the vascular system. And they're solely focused on this thing. And they take a lipid panel and they say, oh, you're either at risk or you're not. When there's really no evidence that panel can tell us anything about your risk of heart disease. And there's actually massive studies that show that that there's no association with cholesterol levels and heart disease, that people who are admitted to the hospital, this was a big study in 2006. I think it was like, it ended up being like 60% of the hospital admissions for heart attack from a certain period of time for a few years. And they found that, when they were admitted, I think 75% had normal cholesterol levels. So if it was this thing driving these events, then you'd think there'd be different results there. But there's a whole backstory as to how this idea came about. And it was, based off some poorly done associational epidemiological research back in the 50s by a guy named Ansel Keys. And America was looking for an answer as to what was causing heart disease, because this is a new thing. So first of all, cholesterol is not a new thing. It's a very old thing that's been around for a very long time. Yet heart disease is a very new thing, only really reaching the epidemic proportions that it's at in the last less than 100 years or so. And how could an ancient thing that's been part of our system for so long be the cause of a new disease, right? And so that research tried to blame saturated fat and cholesterol in blood for heart disease. And it was poorly done research. It was research that's on the lowest form of research. The epidemiological research is the lowest form of research for a reason, because it can't prove that something happens or something causes something else. It can only show an association. And then those are supposed to be tested through controlled trials and things to see if that's true. The only problem is that to do nutritional research is very expensive to do those clinical trials. So most of the nutrition information that we get from academic institutions or government agencies is based on this very low form of research that can really only show association and not causation. And there was a lot of backing behind this theory because there were food companies that liked the idea that they could sell more sugar and grains and vegetable oils if people were convinced that cholesterol and saturated fat were the cause. There was a pharmaceutical industry that had a drug that could lower cholesterol and was like, if the conventional wisdom is that cholesterol is bad, then everyone will be on those and we can make a lot of money. And so that was some of the push behind why this theory took off. And by the time that they heavily tested the theory in the 60s and 70s, because they did, it's probably one of the most heavily tested theories out there. There's 5 or 6 different studies done at that time that were very expensive, showed the exact opposite, that if you replace saturated fat with polyunsaturated fat, then you got more heart disease, more cancer, more all-cause mortality. But those studies were hushed up and pushed under the rug in various ways so that the narrative could keep going because there was been so much investment in this theory. And if you, from like a logistics point of view, if you look at a lipid panel, all it really tells you is what your body is choosing to metabolize at that moment in time. And it fluctuates from day to day. So if you are on a processed food diet or one high in carbohydrate, then you're probably going to have lower LDL and total cholesterol, and you're probably going to have a bit higher triglycerides because your body's taking that glucose and making triglycerides to deliver to the cells. If it becomes pathologic, triglycerides could become very high. So that means like insulin resistant, then they can become very high. Sometimes if people go on more lower carb diets and refrain from glucose, they can see elevations in their LDL or total cholesterol. And that's because your body is trying to package up fats and deliver it to tissues so that you can burn for energy because you're choosing to refrain from glucose, so to speak. And so it goes up because it's trying to deliver more fat. And so those lipid panels can tell us about metabolism. Now, they can also tell us if that metabolism has become pathologic because you're insulin resistant. So a trig to HDL ratio can tell you if insulin resistance is maybe something happening, but really the pure indication of that is a fasting insulin level. And then if people take these subfractions of lipids like oxidized LDL or small dense LDL like particle size and things like that, that can get you an indication of if there's some inflammation in the body. But that's really all it can tell you. And so insulin resistance and inflammation are happening in your lipids, and the numbers in your lipids are not what's driving it. It's the things that are driving insulin resistance and the things that are driving inflammation, low body charge, that are driving that. And so the focus has been on the lipids, treat the lipids, and it really doesn't tell us anything about risk. So heart disease risk is really about clotting. So that's what atherosclerosis tissue is. That's what happens in strokes and heart attacks. It's when the body decides to clot. So that's what we should really be focusing on, which can take us right back to the biophysics if you want to go into that.
Yes, please. I would love to. I personally know quite a few people who are having issues, and some of them are not quote old, where I don't believe in chronological age to actually be a great marker for real age. However, that being said, so arteriosclerosis or other indicators that there's something going on systemically also in the body. So, what can we do in order to, first of all, make sure, check, is there an issue with clotting? And also, if there is, what are ways that we can remedy this?
For sure. And so this takes us right back to the structured water. If we talked about how structured water lines the arteries, and it also forms around the elements of blood, which include red blood cells, lipids, any other protein in the blood, bacteria in the blood, it structures itself around those things. And if we acknowledge the fact that atherosclerosis, which there's plenty of studies that show that atherosclerosis, every aspect of the development of the disease involves clotting tissue, involves thrombin and prothrombin and clotting materials. And when you analyze atherosclerosis in older people, like an autopsy, it's 87% clotting tissue. It is when the body decides to clot. And then we all know that heart attacks and strokes are when a clot forms, and that's very acutely, and that becomes pathologic. And so Rudolf Virchow, back in I think it was 56 or whatever, came up with this idea that the three things that encourage clotting to happen in the vascular system are damage to the lining of the artery, poor blood flow or changes in blood flow, and coagulation of elements of blood. When they stick together, they clump up. And those things are still true today. Western medicine still acknowledges those things are what cause clotting to happen in the vascular system. And so let's review what structured water does for us. Structured water on the lining of the artery, remember, is also exclusion zone water because it excludes anything that's not it. So the only thing that can penetrate it are small hydrated ions of minerals, not anything else. Cholesterol molecules, proteins, anything else in the blood can't really get past it as long as structured water is built and formed there. And it protects the lining of the artery. So there's one. No endothelial damage, no lining of the artery damage if we have intact structured water on the lining of the artery. The other thing is we've already described that poor blood flow is also something. So like when things are just getting backed up and stagnant, they're more likely to clot, right? Like you look at a flowing river is always beautiful and flowing and nothing's really stopping it until we build a dam. And then we build a dam and that water they'll let it flow a little bit, but the puddle will accumulate debris and get dirty because the water's not flowing. And so we've already established that structured water helps move the fluid. right? Keep it moving through the artery. And then third is the coagulation of minerals or minerals of elements of blood. And so I also mentioned that structured water forms itself on the elements of blood, the red blood cells, lipoproteins. And so if we want those things to not stick together, we need to build structured water because structured water is very electronegative. So if those elements of blood, like the two red blood cells like this, they have an electronegative area around them, and this one also has an electronegative area. They don't like each other because they're similar charges, so they stay away from each other. So if we build that structured water on the elements of blood, they stay away from each other. They don't coagulate, they don't clump up. And they've shown this. I think this is one of the biggest things with grounding is that you can look at live blood analysis and you can see the red blood cells are stacked up next to each other like pancakes. They're stuck. And if you do grounding and then look at it afterwards, they're evenly spaced and they're nice and happy all in their own little zone.
What time frame of grounding are we talking about? Is this grounding for 20 minutes, an hour, or with this
So
particular?
this N of one experiment that I saw from someone it was 30 minutes of
Wow.
grounding. It could have been less that they got to that point. I don't know, but that's just what they measured was 30 minutes. So they looked at the blood, it was clumped up. They went out 30 minutes and looked at it later. I don't know if that effect would have happened in 10 minutes or what, I don't know, but that's just what I know. So there's Virchow's triad of the three things. Structured water takes care of them all. Basically what that means is that atherosclerosis is low body charge over your lifetime, right? So that low body charge interferes with the ability of structured water, that interferes with all these things. And if it's this low grade, low charge, low grade inflammation, so to speak, then we can get a slow buildup of atherosclerosis. Okay. And it happens most commonly in coronary arteries because those are the arteries under the most pressure. If there is inflammation, it gets pushed up against the lining of the artery more. And these things that steal charge break down structured water. And so, yeah, and if it happens acutely, if we have a lot of inflammation and then we have an acute stress or we have an acute toxin exposure, things like that, it can damage things very quickly. And that can cause an acute clot where the actual clotting mechanism is triggered to happen acutely. And it's big enough that it blocks an artery, whether it's in the brain or in the heart, or it can happen others like there's liver infarcts and kidney infarcts too. They're just less common. But yeah, that's what causes these things that trigger clotting. And it all comes down to low body charge.
Excellent. Thank you for explaining this, Stephen. And connected to the clotting, I just actually yesterday in a conversation heard something interesting. Maybe you have some input on this. Vitamin K. And people who have issues with clotting should stay away from vitamin K. Now, of course, that's very liked to take, especially in combination with vitamin D, because it has benefits to combine this. What's your take on that?
Yeah, so that's vitamin K1 is the one that's involved in the mechanisms of clotting, all the clotting cascade that happens because your body, the clotting is the thing that it needs to do sometimes. Like if there's damage to something, like you damage your skin, it needs to form a clot so you don't bleed out. And so if it damages the lining of the artery, it gets to a point where it can't repair it, especially if you're insulin resistant, then clotting needs to happen or else the result is worse, like your artery ruptures and you're bleeding internally. So it forms that clotting tissue as a way to repair it. It's just that when it happens too much, that can become a problem. And so vitamin K1 is the one involved in clotting mechanisms. That is one, like if people have excessive clotting, I wouldn't take. But vitamin K2, that's the one it's responsible for taking and placing them, depositing them where they need to go, like in the teeth and the bones and things like that. So people take that for if they have calcified plaque and stuff, because the idea is that if we can increase our body charge and allow the body to start to repair that damage, that the K2 will take some of that and those minerals and deposit them where they need to go, or prevent those minerals from being deposited there and creating this calcified plaque. So there's a difference there between the vitamin Ks.
Yes, excellent. I know in one of our products, as some of the audience who followed this podcast for a while, we research, develop, and also manufacture supplements, are very focused on oral spray supplements, so it gets absorbed via your mucosa. We have 2 of our own brands, and the vitamin D3 that we offer is combined with K2. So yeah, I was just very curious about that. I had a discussion with somebody yesterday who was quite adamant about just K in general.
Mhm.
So as we're talking about this, thank you for your take on that, Stephen. So for people who are concerned about clotting, it is perfectly fine to take the K2, especially in
Mhm.
combination with the vitamin D3.
Mhm.
To reconnect to something that we're talking just about 4 minutes ago. When we're talking about cholesterol, you also briefly spoke about vegetable oils. You're known for being a critic of vegetable oils due to their ill effects on our health. Now, of course, our diets are full of vegetable oils, especially when we eat out or eat ready to go, stick it in the microwave food, whatever. And a lot of these vegetable oils are also marketed as very healthy. Please share with us, what specific risks do these vegetable oils pose to heart health, and what are some healthier fat sources? So, and for omnivores and also people who choose to live without any animal products, vegans.
Yeah. So yeah, the issue with vegetable oils is, again, they're very new. They were only really developed in the early 1900s, so they've only been a large part of our food supply for a very short amount of time. So it's hard for us to really adapt to them. They were not an evolutionarily consistent food, and so the issue is that like your body needs some unsaturated fat, it needs saturated fat, but it doesn't need this really high amounts of polyunsaturated fat that we find in vegetable oils. One issue is that it's a plant fat. So when your body uses plant fat, like this amount of plant fat, like they call it phytosterol, to build up certain structures in the body, they don't function as well. So for instance, red blood cells, like phytosterol is what plants use, cholesterol is what animals use. And so when your body is forced to build more of the red blood cell wall with phytosterol, with those plant fats, they become very rigid and not flexible like they're supposed to be, because red blood cells, when they get into the capillaries, they have to squeeze through and bend to move a little bit. And that structured water is pushing them through, but they still have to bend and squeeze. And if they become rigid, they can't do that as well. And that can cause damage to the endothelia. And there's actually evidence that high amounts of phytosterol in the diets of rats, it predisposes them to stroke. They have strokes more often than rats who are eating more of the saturated animal fats, the cholesterol, so making the red blood cells of that. They've also shown that in humans, like they took a survey of people who were getting ready to have heart valve transplants, and they surveyed them based on their diet, like what do you eat? And they got an idea of how much plant fat, how much vegetable oils they were eating. And they found that there was a direct correlation to the amount of vegetable oil people reported eating and the amount of phytosterol that was built up around the valves they were going to replace when they went in to look and replace the valve. So which suggests that this phytosterol is not very utilizable in these amounts by the body and gets clogged up places and gets stored places that the body can't use it really. So there's a huge issue with increasing the amount of increase in phytosterol through the pervasiveness of vegetable oils in our food supply these days. And then the other issue is that the vegetable oils are very prone to oxidation, especially if someone is in an inflamed state, like they're low body charge, and then they consume these things. They're very likely to get even more damage than they already were before they got in. And that leads to this state of inflammation of low body charge that steals structured water. It's just something else that contributes to the degradation of that structured water. Yeah, these foods, not great for us long term. But the way I like to put it is like nature designed foods in a certain way. Anytime we isolate a specific nutrient, so whether we take the plant that produces sugar and we isolate it down to very processed sugar, that becomes a problem for us. Or we take grains, which I can't say that I think grains are that great regardless, but the more and more we process them down to like flour and then white flour, like the more problematic they are to us. Same with these vegetable oils. Like we take these plant fats, these seeds, whether it's canola or whatever it is, safflower oil, and we process them down to this one constituent, this one nutrient. It becomes very problematic to us because we're not really supposed to get foods in that way. We're supposed to get foods that are very balanced and whole foods that have different nutrients in an array of nutrients, because your body wants, when it wants food, it wants to be satiated. And the way it gets satiated is to getting some energy, though we can get energy from other places that we've talked about, but we can get some energy from food. And it wants proteins, vitamins, and minerals. And that's what food's purpose is. And you will feel satiated if you get all those things. But if you eat a lot of things that are a bunch of calorie, a bunch of energy, and no nutrients, you won't get satiation. And you'll keep eating those calories until your body feels satiated, which may be never, because it's not getting any protein, vitamins, and minerals. And so we just keep eating, keep eating. Whereas if you focus on very nutrient dense foods, whole nutrient dense foods, you're going to feel satiated quicker, which makes sense. That's what your body is wanting when it says, I'm hungry.
Mhm. And so let's talk about healthy fat sources. And I want to make sure we have some good sources for people who eat everything, who are happy to eat animal products, and also for people who, out of whichever reason, whether it's health, ethics, religious reasons, they do not touch any animal products. What are the best choices?
Yeah. I believe that the number one best choice is animal fats. Like you're made of animal fats, you need animal fats. If you choose not to for whatever reason, that's fine. Know that that may put you at a disadvantage, but there are sources of plant fats that are much better than others. Obviously, the vegetable oils we talked about, those are not good sources of plant fat. But if I was going to eat plant fats that are a little better for us, it would be like an avocado or coconut oil or good canola, or not canola, good olive oil that's not full of canola oil, because lots of times they do contaminate them. They're allowed to put, I think, like up to 40% canola oil in olive oil and still call it olive oil. So that's a huge problem. You have to make sure that's real. Same with avocado oil. Like they're allowed to dilute it with canola oil and stuff. So you have to make sure that you're getting a good one. But yeah, like those things. But then the animal fats would supersede those. Yeah.
Mhm. And I know I have friends who I personally am, I would say 95% plant-based. I haven't eaten a steak or anything like that in, gosh, 17, going on 17 years now. I do make exceptions for fish, small fish every once in a while. I have friends who are very much believe in a heavy animal food laden diet. They go for things such as lard. Some of them seem to be doing pretty well with it. Some of them not well at all. That's where I think the one size fits all doesn't fit everyone. I also know the opposite, people who are quite 100% vegan, who are doing extremely well, also biohackers who get all of their blood work done multiple times a year and such. And I know people who don't do that well. So I think a
Mm.
real important thing is to really listen to your own body, to be in touch also with what's happening in your body, get the metrics, have it quantifiable. So with animal fats, what would be your first choices? Would it be something like lard? I know friends who are, vegetarian, they love ghee, the clarified butter
Mm.
out of the Indian tradition. What are some good choices there?
Yeah, I think that I always go for the most nutrient dense ones. So like I wouldn't, as much as like lard and beef tallow and ghee and things like that, those are good fats, but they're just fat, right? I would want to see if I can get fats with more nutrients. So butter has a little more nutrients. Egg yolk has a lot more nutrients, like tons more nutrients. A steak has the good fats, but tons of nutrients, vitamins, proteins, minerals, things like that. I want my food, like my energy fats, or whether it's even a carbohydrate, which I don't do much of because I'm type 1 diabetic and it's just easier, have nutrients with it. And so that's where whole foods are. Whole foods are going to have your proteins, vitamins, minerals, and an energy source. But I think it's also, like you're saying, I think that people can get very dogmatic about diet and they can focus in on one thing that works for them and think that everybody else should do that way too. But I think that when you start to study the physics of the body, like we've been talking about today, you realize that yes, diet is important and you need your diet to get you adequate energy, protein, vitamins, and minerals. But then you get energy from lots of other places. So it's not necessarily about these macros. There's light scientists out there that estimate that only about a third of our energy comes from the food we eat, and the rest is supposed to come from our environment. And if you look at the way that sunlight hits our skin and strikes DHA, which DHA comes from animal foods mostly, then it transforms the light into DC electric current, electrons. Or also when the sunlight hits melanin, which is the pigment in your skin, but it's also concentrated other places in the body. When it hits melanin, it dissociates water into oxygen, hydrogen, and electrons. So like your body can harvest energy from light. It can harvest energy from the ground. It can make its own to get your energy. And then some of the energy, yes, we can get from food, but even that comes from the sun. That's just concentrated in animals and plants. And then we eat those things and try and harvest the energy from them. So the real important thing about diet is proteins, vitamins, and minerals. If you're getting enough of those, stop focusing so much on the diet and being dogmatic about it and go out and get energy other places, because that's what's really creating this life force in your body, this net negative charge that's keeping us alive and ordered and free of disease.
Yes, I love this, Stephen. And you just touched on something that has fascinated me for a long time. I would love to learn more. If you have a light scientist or researcher that you like, that you follow, please share the name with me. Is there someone?
Yeah, Alexander Wunsch. His
Tell
name
them
is Wunch. Maybe there's an
Wunsch.
S in there. Yeah,
Yeah,
Wunsch.
that's German,
Yeah.
German for wish.
So he's had a lot of interesting studies out there, and he's done a lot of podcasts and things. There's also Martin Eade, but he's more of a circadian rhythm type guy. And then there's one guy named, let's see if I get his name right, Arturo Solis Herrera, who's in Mexico, and he has studied the effects of light on melanin a lot. And he has two good books out there. Yeah, there's lots of stuff out there showing that light is driving everything, and we have ways of soaking up that energy or creating that or transferring that light from light to energy. It's really fascinating. Yeah.
It is so fascinating. And I have for years heard about some individuals, sages, enlightened beings, individuals who have devoted their life to meditation, prayer, elevating the frequency for this planet for everybody who lives there. And allegedly, some of them have not eaten food in years and persist maybe even just on a little bit of water. And the claim is that they get all the nourishment they need via light. And there's also I've people online now. Some of this is really you look at some of the videos and claims, and you're just like, yeah, all right. It's just a little
Mhm.
weird, a little bit off. However, the claim is also that you can get to a place where apparently all you need is light. So it's fascinating in
Yeah.
theory. And
It's
here in
interesting. Yeah, it's interesting. And obviously that's not the norm for most people, but there are people that have gotten themselves to that place and they claim to be able to do that. And when you learn about this information that I've learned about, you're like, maybe that's not so far fetched. Maybe there is something to it. I'm not going to choose to do that. I'm still going to get my protein and vitamins and minerals from my food because they enable me to harvest that light even more. But yes, there's much more to our physiology than just diet and exercise, which is the mantra that people say, oh, just diet and exercise. There's a lot more to it.
And thinking about eating light alone, eating, quote, light alone, I think I would miss chocolate chip cookies. That would be a hard one.
Yeah, I heard like in college, I remember hearing someone say, eat 90% of your food to nourish your body and 10% to feed your soul.
Yes, I think that is very wise. And I would say, even you could, even when you feed the soul, when you put yourself in a happy state, truly happy state, I'm not talking about this eating a whole pan of brownies and then you're
Mm,
miserable, you feel bad about yourself. But when you do something that delights you, that gives you joy, I think the way it puts you in a certain state that is really beneficial for you. All the beautiful biochemicals are flooding through your body. And there's something about treating yourself well, and how you take in the food matters too. This is a big tenet of the Ayurvedic school, of the
mm.
Ayurvedic philosophy. They say, do not eat when you're angry or stressed, and eating when you're grateful or when you're happy, when you're relaxed. It really has an effect on how your body assimilates the food. If you're in a happy place and you're eating a piece of cake and you're really in a place of joy, not of guilt, beating yourself up, I think there's something to be said for that. Food will affect you differently. It really also depends on the state you're in. Back to something a little more serious, and because the chocolate chip cookie reminded me of it, as someone with type 1 diabetes, you also have mentioned that you're at a higher risk for heart disease. How does this personal experience shape your focus on your research?
As much as I try, my blood sugars are never going to be as stable as someone else's trying to manage the blood sugars, but they're still pretty normal. But that leaves me at increased risk for damage from glycation. And glycation or advanced glycation in products are things that one of those things that can damage structured water, interfere with charge, that kind of stuff. And so because of that, you're predisposed to damage to the small vessels, the ones that are more prone to that loss of charge. So, like the eyes and the heart and the kidneys and the small vessels in the hands and the feet, which is why like diabetics, have trouble with vision. They're more prone to heart disease. They have neuropathies and circulation issues and things like that. And so everything I can try and do to protect those arteries is what my goal is. So yeah, I mean, that's driven my passion for having all this information, and then using it to help people, because lots of it, when I started sharing some of the information, people were just like, oh my gosh, I never knew this. And I was just like, oh man, um, people need to know this because we have to be educated consumers. And without all the information out there, then how can you make an educated decision? So it's all just about spreading information. I'm not trying to be right about anything or say that other people are wrong or people are on their own health journeys. I just think it's very important to learn from people's experiences, from what they've been through. And I've been through experiences as Western medicine's had to save my life 3 times. And so what can we learn about that? Why did it happen? And what can we do moving forward to prevent it from happening again? And then don't keep it to yourself, share it so that other people may be able to benefit too.
Absolutely. Sharing is so important. Thank you for all the good work you do, Stephen. Something else I want to highlight, especially in the times that we live in, you have often stated that stress really does kill. Could you discuss the mechanisms by which stress influences heart disease and some ways also to mitigate the effects? Most of us are nowadays under pretty much a low level chronic stress, just even, work, family, life. And some people are suffering from tremendous stress, even from for long times.
Yeah, so like acutely, stress increases clotting factors tremendously, which makes sense evolutionarily because if I was feeling stressed, like it would be because I was probably under attack or in danger, which if I got injured, my body needed to be prepared to clot to prevent bleeding to potentially save me from that injury. So it makes sense. However, our very developed brains have gotten us into trouble, especially with the modern day stress that we encounter because we're the only species that can think our way into a stress response. And so we think and we worry about all things all day long because of kind of the state of modern society where you're on your own. Even if you have a circle, a friend group, like it's a modern life, you got to make it on your own. No one's going to pay your bills for you and that kind of thing. So it becomes very stressful. And we can be in this perpetual state of stress, and then we encounter an acute stress, and that increases clotting factors, especially if we're eating a poor diet and surrounded by EMF and the wrong types of light and not moving, like all these things. And then we encounter these stresses that can predispose us to that clotting, that very acute damage to the lining of the artery that can happen during an acute stress. And there's a lot of strategies that people use or can use. One is the more your body charge is, the more resistant you're going to be to that acute stress causing inflammation and clotting. You're building your resilience to that stress. The more things you do, like grounding and getting sunlight and infrared and things like that. But also all those things have been shown to increase your capacity to handle stress, whether it's, which is, we've talked about coherence and heart rate variability. Think about it like this. So coherence, like in a workplace, let's say there's 30 employees and they're all not communicating very well. They all have their own agenda in the company, that kind of thing. And the company encounters a stress. That company's not going to handle that stress very well because those employees are not synced up and communicating and working together. Conversely, if we've got a company they're all on the same page, they've got a common agenda, they're working toward a common goal, they're united, that company encounters a stress, they're going to bind together, deal with the stress and handle it. Same thing in the body. If we've got incoherence, damaged cells, things that aren't communicating, we handle that stress, we're more likely to have this catastrophic event in our bodies. And so if we have coherence where all our cells are healthy because we're doing these things that encourage that coherence, we're grounding, we're having positive social relationships, we're balancing our circadian rhythm, we're eating a good diet, like all these things, our coherence starts to get really good. And those stresses that are going to happen, because stresses in life happen, especially in our modern society, our ability to handle that as a functioning system, our body's ability to negative repercussions or events from that stress. And so things like that. And people have found all sorts of ways to do it, whether no matter what your spirituality is, just some sort of meditation or prayer or whatever you do, those types of things, having a very robust, but it doesn't have to be robust, but a very good, like social, positive, loving social relationships and network of people, very supportive. Like I mentioned, optimizing circadian rhythm, that's huge for creating resilience to stress. But then another thing is, one thing in particular is that if you look at the stresses in your life and the things that are really stressing you out, it's likely the things that make you feel like you're out of control or in unpredictable situations. So they've done studies where they looked at people in the company, like different levels of a company, and they found that people throughout the company reported similar amounts of stress, like as far as the amount of stress. But the people that were lower in the company and had less job security, less predictable hours, less predictable pay, things like that, had way poorer health than those who reported the same amount of stress who were higher in the company and just had more job security, more predictable pay, had control of like it was stress, but they were in control of that stress. They had more say in it. And those people had much better health outcomes than those lower in the company. So when you look into your life, it's the stresses that make you feel out of control or that you can't predict what's going to happen next. Those are the ones you want to try and mitigate if you can. Obviously, sometimes you can't, but those are the ones that you want to eliminate and say, I don't need that in my life. I can figure out a way to build my life where I don't need that type of stress.
Yes, very well said, Stephen. And I think today, at these times, we're at a juncture where things are changing so quickly. The advent of the whole economic systems are getting restructures, certain jobs will fall to the wayside. And there's also such great opportunity. You see, especially a lot of young people who choose not to go the pre-prescribed routes of this is how you learn, get your degree, and then you work such and such, but they jump right in and are entrepreneurial, leveraging what technology has to offer, and are doing often leaps and bounds financially way beyond people who are even 2 decades older. So there's a lot of opportunity to free oneself from stress if one can step out of that fixed mindset of this is how life has to look like in order to be successful, because it doesn't. So people who would like to have really have a look and inform themselves about their own heart health. Let's talk about biomarkers. What are some biomarkers you recommend monitoring for assessing heart health and risks to the heart health, and why?
Yeah. So I'll preface this with my take on testing. So I think that in this world, we have surrounded ourselves with a lot of what I call hyperrealities, which are things that we take as more real than what's actually real. The example I give people that they can relate to is usually the Weather Channel. If you look at the green blobs floating across the screen, you're like, oh, it's raining right there. But I can't tell you how many times I've looked at my phone to look at the weather, and it tells me that what's happening is not what's happening when I'm looking outside. It's very different weather, or at least slightly different. Though what the Weather Channel is reporting, these green blobs, is like this hyper reality, something we're taking as more real than what's actually really happening, that real experience outside. And I could make arguments for lots of things in modern society that are hyper realities. And I think that to an extent, medical testing and medical research have become hyper realities in the sense that we take what they say as more real than what's actually real. And I think that one example is that people go on low carb diets and they see all these health improvements because it's working for them. And maybe their cholesterol goes up. And then they're told, oh, you're going to die, right? Because your testing says you're going to die. And it's just, I just lost 50 pounds and I'm not diabetic anymore. And I'm going to die because I made this change. It doesn't make sense. So this testing has become this hyper reality that your doctor at least is taking as more real than what's actually real, what's really happening. And so that's not to say that we shouldn't look at testing or that we shouldn't look at medical research, because I do those things all the time. But I think we have to take that in the context of what humans have put in front of our faces to tell us the truth, when the truth is really the only way I think we're ever going to know the truth is by what we observe, right? And so that being said, tests for assessing risk of heart disease, I think there are a few that I think are worth looking at. One of them is just markers of inflammation. Again, this is measuring low body charge. So high sensitivity C-reactive protein is one. And there's lots of different tests you could look at for inflammation. You could look at oxidative stress in DNA, or oxidative stress in fatty acids and things like that in your body, which you really get into the weeds. But if it's gotten to the point where your high sensitivity C-reactive protein is elevated, then something needs to be done, right? And then also like liver GGT, which is a liver enzyme that can measure like oxidative stress in the liver. That could be something you look at to see if the liver is stressed, those types of things. And then I think markers of clotting would be helpful. So like thrombin and prothrombin time and D-dimer and erythrocyte sedimentation rate, different things that can give us an idea of Is blood moving? Is it clumping together? Are clotting factors elevated? That type of stuff. And then lastly, I think heart rate variability, probably one of the best out there, although it's still a man-made or man-invented way of testing something. So it's not the foolproof thing. It's not going to tell you, because I have people that freak out all the time. Like, oh, my HRV is super low. But there's still the aspect of, even if it's low, is that your baseline? How do you know? And what happened past in your life that's developed that low number? And it's not just about having this low number, but can you still adapt to a stress at that low number? So there's nuance to it, right? None of these things I put my full weight into. I would never freak out about one test. And I explain this to clients a lot when they come at me with their cholesterol panel. They're like, my doctor says I'm going to die. And I talk to them about testing and these things that I look at. And the other day I see them and they put their blood work down. Okay, so what do I do? And so the way that I like to measure my risk of something is number one, the way that humans have been doing it for most of the time humans have been around is, how do you feel? Did that hurt? Was that good? Did you eat that? Did it not make you feel good? That is a kind of true, real, very real test. And then the other thing is like measure how much your risk is by measuring how much time you spend outside grounding. How much sunlight do you get? How many positive, loving social relationships do you have? Do you love your job? Do you hate your job? Like, these are things that are really going to tell us more about risk. And we're based more in reality to me, rather than these hyper realities that can give us information. But just like the Weather Channel can give us information, but it's not going to tell us what's actually happening. And we have to keep that in the context of things, because I know people with perfect blood work who feel terrible. And I know people with blood work that looks quote unquote terrible and they feel great, like I was talking about. So it's just, we have to take that all into account and be educated consumers of some of these hyper realities.
Yes, indeed, Stephen. And you've also emphasized the importance of having a philosophy of health.
Mm.
Can you talk a little bit more about that and share about your own and how others can develop this philosophy of health?
Yeah. So I think that lots of times people get confused these days because there's so much health information out there, and everybody's saying that this is what'll fix you, or this is the best diet, or you take this supplement and it'll fix everything. What's true and what's not. And so I think that having a very real philosophy of health makes it easier to determine what's good and what's bad, or what's right for you and what's not. I won't say what's good and what's bad, what's right for you and what's not. Because what does that mean? It means that for me, my philosophy of health is that when I look back at why life is here in the first place, it's because at some point, some cells figured to maintain order, and it became a multicellular organism that became a bigger multicellular organism. And over time, it grew until eventually one day humans are here, right? First it was marine life, then marine plants, and then marine life, and then animals, and then lizards, and just everything happened, So taking that into account, when you realize what life is, the ability to harvest energy from your environment and maintain order, helps me do that, must be good for me. And anything that interferes with my ability to do that must be bad for me. And anything that is doing neither is probably a waste of money. So when you think about that, I've put my body in a situation that harvests energy from the environment. Is the sun bad for you? There's no way it could be. It's literally what's powering everything on Earth. It's the reason that anything is here, that any life is here, and it's the energy source that's sustaining any life on Earth. How could it be bad for us, right? Is cholesterol causing heart disease? Your body's been making cholesterol since humans evolved. Like, how could it be bad for you, right? So that's my philosophy on things. And then when you look at modern research and modern evidence that's backing these things up, as far as like how good the sun is for you, how good whole, natural, nutrient-dense foods are for you, and how bad the processed foods and processed light and all these things are for you. There's modern research that backs that up, but I don't need it because I have this health philosophy that tells me, yeah, this is better for me. Now, if I go and I do all those things, I put myself back in that environment where I'm harvesting energy again, and there's still something wrong because of, I don't know, a past trauma or autoimmunity when I was a kid. Now I'm type 1 diabetic. Then there's things that we can look into, but you have to get that baseline environment right first. Once you do that, then we can start to tweak things. And that's where maybe some research becomes more useful? Is this good for this or that? But it all has to be through this philosophy of, to me, what is real versus not real. What is real? What have humans and life been exposed to for the billions of years that they've been here? The real things, the sun, the earth, other humans, other life, that type of stuff. No toxins, no processed foods. Like those haven't been around very long. Like that's the real. That's when I ask myself what is real, those are the real things versus the artificial things.
Mm, yeah, I like that, Stephen. And I think developing a philosophy of health is a tremendous practice. Is there any other practice that you'd like to share with us that has enhanced your human experience, whether it's physically, mentally, or spiritually?
I think just being curious, like it keeps me like even in tough times in my life where if I experience health setbacks or relationship setbacks or whatever it may be, like my curiosity is what pulls me through. I've been in relationships where there was past trauma and now I have my own past trauma. So then I went headfirst and diving into trauma and reading all these books about trauma. And like that curiosity keeps me moving, keeps me educated about the thing. And I get new perspectives on those things, but it also furthers my understanding of health when I do those things. And it pulls me through those, and that curiosity. And it also somewhat distracts me from the negative feelings I may feel because of those things. And so I don't dwell on them and sit there and in my self pity and stuff. I literally have this purpose of moving forward. Understand this so that you can figure it out. And there's plenty of studies that show that people who have more sense of purpose in their life live longer, right? And people who may work their whole lives and then they retire, their health starts to decline because their work was their purpose. So even if you do retire from a job, have some sort of purpose, something that you're doing that helps you move forward, some curiosity, I would say, to things about the earth, and don't get caught up in these things that tell you what your truth should be. Go and find your truth, right? And use that as something that keeps pushing you and motivating you to move forward. Because I think that's done wonders for me, and it's what keeps me going.
Beautiful. Thank you for sharing that, Stephen. And also when we're talking about purpose, I think the amount of people who, when their children are actually lovingly sat down by their parents, asked, "What is your soul calling for? What has most meaning to you? What brings you most joy?" is the number of people that experience that type of blessing is very small. So many
Mm,
of us go into believing purpose is this 9 to 5, and then
mm.
on the weekends you get drunk. That's your joy.
Well, that's their escape from the
Exactly.
reality that their body is telling them is not their passion, right? They're not enjoying life, so they have to go escape, which is what the alcohol and things do. They give you this temporary escape. It doesn't fix anything, but it gives you that temporary escape.
Yeah, or then your 1 or 2 weeks vacation and you go on a cruise ship all inclusive, and again, the alcohol, the escape, and then all of a sudden you retire, and then most of us don't even have the tools to think about, "Wow, next chapter," but we just feel depleted and we crumble
Yeah.
in on ourselves, and then diseases start to kick in anyhow. But so
Yeah.
I love that. Purpose is so important. Curiosity can help us find the purpose, and I also really love what you said about purpose, about curiosity in a sense of curiosity turns something that is difficult or an issue or problem actually into a gift.
And create a life that you don't want to escape.
Those are great final words. Stephen, thank you so much for joining us today. It was really a pleasure. I could talk for another 1.5 hours at least with you. There's so many things we haven't even touched upon, but maybe we'll do that in a next session.
For sure. Yeah, it was super fun. Thanks for having me on.
Thank you so much, Stephen. Have a beautiful day.
You too.